You're probably using it every single day, whether you realize it or not. But today, we're pulling back the curtain to dive into exactly how artificial intelligence actually generates language. Welcome to This Explainer. We are going to deconstruct the seemingly magical tech that is completely powering our modern world. Let's get right into it. Think about the last time you asked an AI to write something for you. Maybe a birthday message for a really good friend. You start with a basic prompt, and then you just naturally tweak it step by step, exactly like a normal conversation. You type, make it funny. Then, actually, make it a little shorter. And finally, make it sound more personal. You aren't typing rigid code or complex programming commands, right? You're literally just talking. And remarkably, it seems to perfectly understand exactly what you want every single time. But when you simply talk to a computer and it appears to understand you on such a deep level, we really have to stop and ask the million-dollar question. Where did that response actually come from? Did the AI just rummage through a massive hard drive to find that exact pre-written sentence, or did it create it out of thin air? And if it created it, how on earth did a machine know what to write? Well, this incredible illusion of understanding is driven by what we call a large language model, or an LLM. An LLM is an AI model that learns patterns from vast amounts of text and then uses those learned patterns to process and generate human language. It is definitely not just copying and pasting files from some server in the cloud. Instead, it's actually learning the intricate underlying rules of how we speak, allowing it to build highly complex responses entirely from scratch. So when you ask a simple question like, "Why is the sky blue?" the model processes your words, considers the context of your question, and essentially predicts what makes the most sense to say next. It doesn't spit out a complete pre-written paragraph all at once. It builds its answer step by step. It writes one piece, evaluates, and writes the next. But what does predicting what comes next actually mean in this context? To truly get a feel for this prediction game, I want you to mentally fill in the blank in this sentence. I didn't sleep well last night because I didn't get enough. You probably instantly thought of the word sleep, right? Your brain didn't have to go query a database to find the answer. You just inherently knew it based on the natural flow of the sentence. Or how about this one? The children are playing in the surrounding context words give you all the clues you need to confidently predict that the next logical word is park. You didn't memorize that exact sentence in school. Your brain simply used context to predict what makes the most sense to come next. An LLM plays this exact same prediction game, but it relies heavily on mathematics and pieces of text called tokens. Think of a token as a tiny puzzle piece. It could be a complete word, maybe just part of a word, or even just a single punctuation mark. The AI calculates the most mathematically likely next puzzle piece to add to the chain, over and over again, rapidly building out the response. So the actual flow looks a bit like this. The language you type is chopped up into these token puzzle pieces, pushed through heavy mathematical processing, and rebuilt into a generated sentence. It takes human language, breaks it into pure math, and turns that math right back into human language. It's essentially a translation of ideas into numbers and numbers back into ideas. Pretty wild, right? But before it can predict anything accurately for you, the model has to go through a massive training process. It digests enormous amounts of text to learn foundational rules, how words commonly appear together, how sentences are structured, and the natural rhythms of human communication patterns. It's kind of like reading the entire library of human knowledge just to figure out how we naturally chat with each other. Now, if it needs so much information to learn these patterns, it brings up a very obvious and important question. Why exactly do we call them large language models? What makes them so large? Large literally refers to the astronomical scale of the model. We're talking about massive data sets, processing huge chunks of the entire internet using incredibly powerful computing systems. It also refers to huge numbers of internal values called parameters. You can think of parameters as billions of tiny mathematical dials that are meticulously adjusted during that training phase to hold all those learned language patterns firmly in place. This brings us to the fascinating challenge of context. Imagine the phrase, "I went to the bank to deposit money." Now compared it to, "I sat on the bank of the river." The exact same word has two entirely different meanings, and you only know which is which because of the surrounding words. For a long time, computers completely struggled with this kind of nuance. To solve this context problem, modern LLMs use a complex mathematical architecture called a transformer, which features a brilliant mechanism known as attention.
This allows the model to mathematically weigh all the context and determine which parts of your prompt it needs to pay the absolute most attention to. It maps out the hidden relationships between different words to figure out exactly which bank you mean before it generates a single token.
That attention to context and those beautifully learned patterns are exactly how an AI can invent a totally new, completely absurd story about, say, a robot bakery on the moon. It is not searching for a pre-existing file on a server about space baking robots. It's mathematically combining patterns it already knows about stories, robots, bakeries, and the moon to seamlessly generate a brand new sequence of words that has literally never been written before. But if it can generate incredibly convincing, highly original language that sounds perfectly human, we have to step back and ask a critical question. Can we trust it entirely? Or can this highly advanced technology actually be wrong?
Yes, it can absolutely be wrong. Generating convincing language is definitely not the same thing as guaranteeing factual truth. This leads to what we call an AI hallucination, when the system generates an answer that is incredibly detailed, highly confident, clearly explained, and completely false. It predicts a great-sounding sentence that just happens to be a total lie. And this is exactly why you have to be super careful when using these tools for serious tasks.
Because LLMs can hallucinate, they're often just one component of a much larger system. A functional AI application does not equal an LLM alone. In the real world, developers connect the LLM to external databases, search engines, or business software to fetch actual, hard facts first. Then, the LLM uses those verified facts to generate a natural-sounding response for you.
And this brings us to the absolute necessity of professional technology judgment. Rather than just grabbing the biggest language model available to solve a problem, we have to pause. What problem are we actually trying to solve? Can an LLM even help us here? How accurate does it need to be? And what is the fallout if it makes a mistake? The goal isn't just to use advanced tech for the sake of it. It's to use the right tech for the right problem. All right, let's tie this whole mental model together. You provide the language. The LLM processes that text and context. It accesses its massive database of learned patterns, mathematically predicts the very next token, and generates the response piece by piece until you have a complete, human-sounding answer right in front of you. The next time you ask an AI to write something, remember, you aren't talking to a static database of facts, but to a highly advanced mathematical prediction engine. Which leaves us with one final, vital question. If this incredible illusion of understanding comes from a machine learning massive patterns, how exactly do these models learn from all that data in the first place? What does that training process actually look like? Keep that question in mind as you continue your journey.